Alright, let's do this. So, you lucky guys are getting circle theorems today. So, this is the format I'm going to do it. So, I've actually got a bunch of questions which are above the screen and below the screen. So, now, instead of telling you all the circle theorems at once and then saying, alright, let's do the questions, because that's going to be way too much for you to remember, I'm going to do maybe say 1 or 2 circle theorems at a time. Then we're going to look at the questions. And that should kind of make it easier to digest rather than trying to figure out 8 or 9 brand new circle theorems all at once. So before I do circle theorems, let me tell you about circle theorem questions, because really that's all you care about. So yeah, I mean, they're going to look something like this, and I'm sure you've seen them if you've seen any papers or anything. The thing with this is, so if we have a look at this question, you know, you're going to be asked to find ACD, which is that angle. By the way, when they say ACD, it just means, can you see ACD? So it's that actual angle there. Or another way to think of it, it's actually just the middle letter, which is the angle you're trying to find. Now, here's the general rule for circle theorems. Just try to find any angles you can. I mean, if the question's obvious, sure, answer it. But otherwise, just try to find any angles you can. So they're telling you to find this one, but if you can't find that one straight away, try find this one, try find that one, just find anything. Because generally, the more angles you have on the actual question, the easier your life will be, basically. So, okay. So that's just a general rule. So, okay, so here's the first circle theorem. So I want you guys to imagine a circle. It looks like a circle drawn in like Player Year 2. But right, and now I want you to imagine a chord. And all a chord is a line a line between two points of the circle. And, you know, it would just kind of look like that. But I've done that in, let me do that in a different color, just to kind of show it a little bit more. And I'll do it like dashed. Okay, so imagine that. Now imagine we have a triangle where one of the sides is that. Can you see that, you know, let's imagine another point here. So can you see we've kind of made a circle with 3 points there. And this is what the circle, so I'm talking about a triangle. And that's what it will look like. Now, imagine there was another triangle which used the same chord. Yeah, the same chord. And the reason I say this dashed wise like this, yeah, is, can you see this one? Can you see this line here? Well, that kind of makes a triangle. It's because they won't always give you this line, but they will give you these two things. So it's almost like you've got a... But the chord is the most important thing with it, that chord. Now, imagine that this is 70 degrees. Now, if you have another triangle which has the same chord as one side, so basically these 2 points are 2 of its 3 edges in a way. And imagine now you've got the 3rd edge is like there. So it looks like that. Well, here's what the first circle theorem is. And all a theorem means it's a rule. It's something you have to remember. It's not really like algebra, you know, which can make sense when you start knowing it and understanding how it links between. These are just boring bloody rules which you're going to have to remember. Probably the most dullest part of the actual syllabus, in my opinion. That's what I used to find. So anyway, so do you remember we've got this triangle here, and that we know that's 70. Well, it says if we make another triangle which has the same chord like that, that's exactly the same. So these 2 have to be the same. So if I just made another one, say, again, coming from the same chord, that's crucial. You see that one? That would also have to be 70. Even something like this, even if the third point was like that, so you imagine something like that, even that there, which I've run out of space, will be 70 degrees. Okay, so now here's another kicker. So let's kind of just do another one. So imagine you got these 2 things, yeah? So you might get a question like this. And I hope one day I actually learn how to do straight lines with this actual program. Because until then it just looks like some primary school drawings. But until then, you bear with me. So yeah, look at that. So you might, well, I've already told you the answer there. Well, okay, imagine you didn't see that. So here you go, you've got a circle. You've got these two triangle things happening. Now, they might ask you, oh, what is this? And your thinking has to be like that. So basically, I want you to think about this triangle here. Can you see basically it's got like this chord? Can you see those 2 points are the same for this and this, or you could think of it as a chord. Either way, think of it. Well, because that's that base, and it just means that that has to be 40 degrees. Hopefully that's sort of clear. Okay, so another kicker now. So what if I told you this? So we'll do another question. Alright, so say this is 83 degrees. What is this one? Now hopefully you guys kind of said it's 83 because you know it comes from the same chord. So that's really the first circle theorem. Now here's another kicker. Notice all this time I've been going from this chord, all the other points have been here, here, here. Basically on this side, because really the chord cut into two pieces, didn't it? Piece 1 and piece 2. Now, so we've been doing this, you notice this was in piece 1, this was in piece 1. What would this one be? Any idea? Now you might want to guess 83. Now you'd be wrong. So you might say, if I asked you what is it, here's the thing, you can't tell anything. You have no clue what that thing is. Basically it means if you've got a chord and the third point is on one side, well then any other third point on that side will have the same angle at that point. But the other side, you know nothing. You know nothing. However, if someone told you that this one was 53, then yeah, this one would also be 53 because it's on the same side of the chord. So basically, in short, if you picture this was a chord coming from these 2 points, if the third point's here, you know that's 52. Well then as soon as you have another angle like that, that's also 52. But if you know something, and if you knew this one, this by the way is not 52 because it's on the other side, you know nothing. There's no link. It's not like these two add up to 180 or nothing. There's no link. Well, actually we'll find out later. But yeah, imagine that's 33, and if there was another one, that would also be 33. Okay? So let's... This is actually properly like a whiteboard. It still stays a bit dirty after I rub it out. Alright, let's see if I can sort that out. Let's just sort that out. So okay, so let's have a little look at a few questions. So alright, and here's what we're going to do. Remember the rule. We're going to go through every question. I think there's like 14 questions. And we're just going to look at each one of them. And your aim is, look, what angles can I find? Can I find any angles? So let's think about this. And we're just, I mean, I know the question's saying, look, find this one, etc., etc. But, yeah, I'm just going to try to find as many angles as I can. So they're basically saying, find this angle, ACD, which is just the middle one we care about, angle C. Now, here's how you find out. Can you see in this one, yeah, AD is a chord. So I just want you to focus on this bit. Yeah, do you see how that makes a triangle from this chord? Can you see this also makes a triangle from the same chord? That means this one must be the same. So let me just rub the red lines out. Yeah, this one's 54. Similarly, actually, if you want to find this one out, you actually could. And it's actually about this exact same logic. Look at this chord. Do you see how that one creates like a triangle like that? Touching the edge of the circle. By the way, it's always the edge of the circle. Always the edge. So you've got a chord and it touches the edge of the circle. And here's another one. Do you see that touches the edge of the circle? So because that one and that one, as soon as I'm told that one's 28, this one has to be 28 too. Not that this question asked you for that, but hopefully that makes sense. So this one too, this one is 28. Okay, hopefully that makes sense. Let's go into this. Well, there doesn't seem to be many chords. I mean, we got that chord, but there's no point going to the edge. There's nothing really much there. You know, you're looking for that common chord. You're looking for a common chord. Is there anything here? No, I don't think so. I don't see a common chord. Anything here? Nah, there's no chords whatsoever. Alright, so let's have a look at a few more questions if we can see, find anything. Here, no. Here, no. Okay, this might be interesting. Sometimes this catches people out because they're like, look, B, yeah, BD is a chord. They might be thinking, well, if I told you that's 20, they might think, oh, well, that's 20 as well because that's a triangle, which also comes from the same chord and makes the same point. No, this would only be true if the point was here. It's got to be, the third point has to be on the edge of the circle. Has to be on the edge of the circle. Right? Anything here? So basically here, nothing. No, nothing. Here, number 9. Nah, we don't know anything. This one, do we know any of the angles are the same? Well, actually, this one's not easy to spot. So I want you to imagine this. If I told you that this one's 25, do you have any idea what another of them would be? The answer is, so some people jump to, they're like, wait, CA. Do you see A, B, and C make a triangle? Well, then they might be like, well, look, here's another triangle, but that's the same mistake. Notice how this point was on the edge. If this was here, then yeah, that will be 25. But you can't say anything about that just yet. So basically, no, you don't know anything yet. Anything here? No, so it looks like that's the only one which uses that. But that's a really important one, by the way, so you've got to be happy with that. So let's go to the second rule. The second rule is actually just a special version of the first one. So you know how two triangles with the same chord give you the same angle as long as it's in the same side? Well, here's the thing. Imagine if you have the diameter. And the diameter is just a special version of a chord, really, because it's the one which happens to go through the center. Now, this is what they call angles in a semicircle. Not that you need to know that name in any way. So this one always makes a right angle. So if you have 2 points here, which join to there, that's a right angle. So it doesn't matter if it's there. So basically, 2 points which are the diameter, third point on the edge, always a right angle. And this one doesn't really care about which side. Even if you do it here, that's also a right angle. Because the whole fact is, if you take that chord, you're just going to get 2 semicircles. Can you see that? So if I have if that's a right angle, well then this one has to be right angle because it's the same sections. Do you see what I mean? So that's just a special case, and so I want you to look out for that. So that's just a special case of the last one. So you know, you might be given something like this. You're told that's a diameter because they tell you that's a center, and they might ask, you know, a question might ask something like this. Might tell you that's 42. They might ask you, well, what's this? So this is where you've got to use your logic, because that's, you know, you've got a chord which is the diameter and it touches the edge. Well, you know that's a special version, and that's always 90 degrees, so you have to understand that. So as soon as you know that's 90, you can add those two together. You know all of them add to 180, so 90 plus 42 equals 132. And this one, all of these three have to add to 180, so you do 180 minus 132, which equals whatever it equals. So that's the second one, and I have a feeling none of them have it. I have a feeling none of these questions have it. Can we see anything there? No. I mean, for this one, you'd be looking for the diameter anyway. If the diameter is not there, there's definitely, look, there's no diameter here on this. There is a diameter here, so you might be kind of looking out for it. But no, it doesn't look like, if there was, so basically on here, yeah, if you had a triangle like that, this will be a right angle, because that's a diameter. That's touching the edge. That'll be a right angle, but obviously it's not there. Anything here? Nope. Okay, can we see a thing? No. No, there's no diameter. Remember, that's not the diameter. There's no diameter here. There's no diameter here. No diameter there. No diameter there. I don't think we have a thing. It will come up. Expect this to come up. Just remember that. Ah, okay. Have a look at this one. Have a look at this one. So they want you to find out ABD, which you can't do yet. But here's what we're doing at this stage. Do you know any angles here? Can we work out any angle whatsoever? And the answer is yes. Look, that's the diameter. And that's touching the edge. So this is a right angle. Oops. Right angle. Now, automatically that gives us another angle. Gives us this one, doesn't it? Because we know that's going to be 90 at 35. So that's going to be 90 at 35. It's going to give us 125. Do 180 minus that, because that's what that has to be. 55. So we actually know this is 55. And I'm going to leave those things, because eventually we're going to try to find this angle. So all of this stuff is going to help us, basically. The more angles we know now, the easier it's going to be when we have to answer these questions. Oh, actually, and that is actually part of it. It goes, find the angle DEB, or DEB is that one. So that's actually that one sorted. You see that? That's 55 degrees. I guess, let's see if we know any others. Do we know? There's no diameter there. Alright, so that's that one. That's the second rule done. Oh yeah, ACD. So that's, what was that one? 54 as well. So yeah, that's fine. Okay, so next circle theorem. This is an important one. They like this all the time. They call it double angle theorem, or double angle theorem. So here's the deal. So let's have a look at that chord again. So imagine there's a chord. They love chords. Here's a chord. Now I'm interested in 2 points this time. I'm interested in center, and I'm interested in the edge. Let me not do the edge there. Let me do the edge there. So imagine you've got this triangle here. So it's coming from the same chord. Yeah? And imagine if I tell you that's 50. Now I want you to imagine this one. So this one comes from the same chord, but this time it touches the third point is on the center, not on the edge here. Well, here's what this rule is. So basically, this is the double angle theorem. It goes, when this angle will be half of that angle. Or another way to think of it, this angle will always be double that. So this one's going to be 100. And you know, there's only really two ways which this question is going to come up. And again, you've just got to be thinking about this common chord, because it won't always be there. So here's how it might come up. They might show you something like this. Now, it's, you know, that's the way they're going to do it. They might tell you, well, what is this? You know, they might tell you this is 42. Well, you have to understand, look, it's coming from this same chord. Can you see? And this is the center, by the way, yeah? Well, by that rule, this one has to be double that. So that would be 84. The only other way it could kind of come up would be, I guess, the flip way around. Which would be, so you've got this thing like that, and the other one, say you've got something like that. That doesn't even look like the center. And they might tell you that this is 102, and ask you what this one is. Well, this is just the opposite, because you know that has to be half of that. You just do 102 divided by 2, so that one becomes 51. Now, there is a way that this question actually tends to catch people out, and here's how it is. And hopefully you see the logic from one of the earlier ones. So, you know, they might have center like this. And then you might see another triangle with like a point like here. So if I do that in green or something. and they might tell you that's 44. Now, that's not obvious here. But this is actually the double angle theorem. And so basically this will be 88, but let me explain more why. And this comes back from the first rule that we learned. So do you remember this thing? Basically, imagine I got 2 points here, yeah? So it says if the third point is like up there, and I tell you that this is 58, and there's a third point even down here. It doesn't really matter where it is, but it's the same chord. That's where the third point's coming from. Well, that one's also 58. So the only thing which catches people out here, so you've got to imagine, if there was another triangle here, which if I kind of colour in blue, was like that. Now I just want you to ignore the black one for a second. Notice that these are all coming from a common chord. And you see by logic, the green one and the blue one would have to be the same by that first circle theorem. So this will be 44. Now ignore the green one right now. Then if they just gave you this black and blue one, most people were happy like, oh yeah, that's 88. However, if that blue one isn't drawn, that blue one isn't drawn, well, you know, you've got to basically see that, you know, if I move that point all the way here, then you'd recognize it. But sometimes they might kind of do this weird one. What you've got to look for is this chord. And you think, is one point going to the edge and was one point going to the center? If so, this is going to be double that. So this one will be 88. So I guess that's the next one. So let's have a look at some of the, see if we can kind of spot some of these. Well, there's no center here anyway, so we definitely know it's not going to be that. Now this is a good one. So they want you to find out this angle. Remember, we're just trying to write this point just to find out anything. So I mean, like, look, if we didn't know anything else, we could probably find this one out, couldn't we? So we just, you know, we'd have to know that this whole angle around the 0, or O, or center, will be 360. So, you know, what's 360 minus 168? I think as a 2, I'd know that off of my head. Here you go. That's 192. So we know that. Now, do we know another one? And the truth is we do. And here's what I want. So let me just move that aside for a bit. So I'll just kind of say like, so we know that. So that will be useful. Now I want you to see if you can figure out this one. Because here's the deal. Can you see this is a common chord? Do you see that from this common chord, one point goes to the edge, the edge, and one goes to the center. So can you see that this one is going to be double that one? So that one is half of 168. This one is 84. Does that make sense? And we know that this one all the way around here is, what was it, 192. So these are all helping us. Do you see? I mean, even though the question is asking us this, yeah, you can see it's a 4 marker and it relies on other angles. And you'll see in a bit that this will actually help us massively to find that out once you learn one of the other circle theorems. But you know, this is the logic. When you see a circle theorem question, start getting in anything you can notice, angle-wise, you can figure out, just put it down. Just put it down. This one here, no, there's no, nothing. Remember, we're thinking about a chord and something which goes to the center and then a point on the edge. Here, nah, I don't think we're going to find any angles using this thing. This one here, nah. Anything else? Oh, here's number 6. No. No. Okay, do we know anything here? Yeah, well, we don't know any angles just yet. But let's say if I draw this chord, we don't know, but whatever that is, we do know that that's going to be double it. But we don't know what that is yet. If we knew one of these, we know the other. But, you know, it's nice to kind of put down. What about here, number 9? Have a think. Yeah, and if you got this right, it's really like, if you can spot that chord, can you see, look, from that chord, one goes to the center, one goes to the thing, so that means that this is double that. This one right here is 140. 140. I'll give you a reason. It's like, I don't know, it's double. You know, you can just say, you can either say double angle theorem or something, double angle theorem, or you can just say maybe like BOD, which is that angle there, is double BAD, or you could even say something like double 70. Don't worry about this too much. But anyway, so yeah, that should make sense. Anything here? Well, this one's actually, you can actually do this one. You should actually know something about two of these angles. And this one is the one which I said is hard to spot. So I want you to imagine CA. Okay, CA. So whilst we don't know, you've got to notice that if this thing was over here, yeah, imagine another triangle like that, yeah? Well, if I told you that this is 40, well, can you see that would automatically be 40? And this would be 80? Yeah? So actually this one is always the same as that one. But seeing as that one's always half of that one, this one has to be half of that one. That was a little bit of a tongue twister. But yeah, if I call this one X as well, yeah? This one is going to be double, whatever that is. Because it's the same thing, it's that chord, and the third point is at the center, another point is at the thing. I mean, to be honest, I wish there was a better way of explaining these, but these are just memory tests, sadly. Nothing here, and nothing there. Alright, so now let's move on to the next rule. And you might, I mean, look, well, yeah, let me just forget. Bloody hot day today. Okay, so let's have a look at this. I'm opening the window, give me a second. Okay, so let's go to the next point. Pretty easy one actually, this one. You got a circle. Now, this is just called, I think, what's it called? Cyclic quadrilateral, which just means, imagine you got a quadrilateral, which is a four-sided shape. So imagine the four edges are on the edge of the circle. Doesn't matter where they are. But look, here's the thing. They make up a thing. Now here's the rule of it. And this only happens if it's in a circle anyway. Normally this doesn't work with any quadrilateral. But if I know that's, basically here's the deal. Opposite sides add to 180. So these two will add up to 180, and so will these two. So let's see how that will be useful. So if I told you this 40, well, that means because 4 points are on the edge. By the way, sometimes people make a mistake on this. Sometimes they'll see a quadrilateral like this, and they'll think, oh, these two have to add up to 180. No, 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 no. The quadrilateral has to be on the edges. Has to be on the edges. So not this one. Well, yeah, so basically here, they are all on the edge. This will be 140. Because these two have to add up. Similarly, if I told you that's 71, well, this one would have to be 109. Because these two have to add up to 180. Reasonably simple. Okay, so I might say, so can you work out this angle, can you work out this angle? Reasonably simple. You know that these, firstly, you've got a quadrilateral where its points are on the edge of the circle. That means opposites sides have to add up to 180. So these have to add up to 180. So what is 180 minus 34? This would have to be 146. These have to add up to 180. 68. So, okay, so let's have a little look around. No quadrilaterals here with all the edges on the side. Now here, this will actually help you answer this question. Can you see that A, B, C, and D, these 4 points are all on the edge? That means this angle and this angle would add up to 180, and this one and this one. Well, look, the question is actually asking for D. Because you know that one, you now know this one. This is going to be 100. These two are going to add to 180. So do 180 minus that, and you find that's 96. So look, we've now answered another question. Here, no. Now don't be confused here. Again, some people might think, oh, does this one and these one add up to 180? Do these two add up to 180? Absolutely not. Firstly, this point isn't even inside the circle, so that's definitely not going to work. And this one's the center, which isn't on the edge anyway. So does that make sense? Here, nope. Let's have a look here. Again, don't be fooled to think that one is. It's not. This one, no. Here, no. Here, yeah. And this one's going to help you find a lot of stuff. Now, can you see, again, A, B, C, D. This one, not this one. Not the inside one, because O, what was I going to say about O? This one's not on the edge. So this one is not gonna have the opposite angles added to 180. However, this one is a four-sided shape with all the points on the edge. So okay, so basically where that's going to help you is we know that this one and this one have to add up to 180. So immediately there you know that this is 70, not 70, 50. Yeah, because these two have to add up to 180. Now remember from before, we knew that this angle here is going to be half of that one there, or you could say this is double of that. So immediately you know that's 100. Do you see that? And actually these are the two answers. So you first had to find out what BAD was. Well, that was 50. ODC, which was, where was ODC? Oh, that's this one. Okay, so I guess we don't actually know that. Yeah, we don't know that yet. We don't know that yet. But we know that one's 100. So I'm sure that will come in useful as well. And yeah, just remember, keep putting down as many angles as you can. Do you see how earlier we just find stuff out and that helps? Yeah. Similarly here we're going to be able to find out y, because that's a quadrilateral with 4 edges on the thing. That's 170, that means this one's going to be 110. Opposites, yeah. And you know, don't worry about the two reason A, B, C, D is a quadrilateral with edges on circle, therefore opposite angles, or you could say DAB plus BCD equals 180. Honestly, don't worry too much about the wording, just write what you know, and trust me, you will get it right. This one, no, this one quadrilateral. Is there anything here? Nah, nothing. Alright, so let's move on to the next one. I mean, it's a pretty boring subject, circle theorems. Takes a little bit of practice, etc., etc. But yeah, that's yeah. What can I say? It's just dull. I feel sorry for you. All right, so here's a good one though. This is what they sometimes call sneaky isosceles. So here's the deal. You might be given something like this. So imagine this is center, yeah? Someone might tell you, someone might ask you this. They might ask you, they might tell you that this is 70. And they might tell you that this is 70. No, what am I doing? Imagine I didn't say that. They would ask you, what is this? Well, you probably have a feeling, because I kind of gave it away. But imagine you didn't know. What would it be? How would you know? What would it be? Well, here's the logic. You've got to understand that these two sides here, this side here, this side here, it's the radius. Yeah? So this one is the radius. This one is also the radius. So you have a triangle here where basically these two sides are the same. Well, what does that make it? That's an isosceles. Now, pretty much everywhere else in the syllabus, if they're dealing with the isosceles, they will have these two dashes. In circle theorems you won't, and it will always be from two radiuses. So as soon as you see two radiuses, you should be thinking that's an isosceles. Can that help me? So let me give you an example of this question. So they might give you something like that. they might tell you that this is 100. They might ask you, well, what's this? We have to kind of think about this and say, well, that's the radius and so is that. So this is an isosceles triangle, which means these two angles have to be the same, x and x. And then, you could either kind of you can also just logically think, well, x plus 100 has to give me 180. So these two things have to add up to 80. Each one is 40. Does that make sense? You can't answer back to me because you're watching me, but hopefully that makes sense. So yeah, here's what let's go back to the questions. Let's see if we can see if there's a triangle where two of the sides are radiuses. Here, no, there's no center. So first, if you don't see the center, then you definitely don't have radiuses. Here, this question's pretty much done. But I guess in a way, if someone asked you, well, what's this angle and what's that angle? Can you see that's like this is a radius, that's a radius? So you could actually work that out, that angle out actually. Well, you know that all of these have to add up to 180. So you already got 168 there. So these two have to add up to the remainder, which is 12, and you've got to split them equally. So that'll be 6 and that'll be 6. Kind of interesting. You could probably that's what you could really do. Here, well, no. Well, if there was this one, can you see that's a radius, that's a radius? These two will be the same. But don't draw your own lines in and try to find out what the angle is. That's just too much effort. No lines even coming from the radius there. Let's not bother with that. Here, and this one's going to be useful. This one's going to be useful. So you're told that's x. Can you see these two are radiuses? Well, yeah, you know straight away that that's also going to be x. But yeah, you don't know much else apart from that. And by the way, don't be fooled into thinking these two add up to 180. You don't know that yet. They might, but you don't know that. Here, do we know anything about the angles? Not much. I mean, I'm not going to. So, but we do know these ones are the same. I'm going to call those y because that's x there. See that? So once I find out that one, or if I find out that one, then I can find these two out. So you see, that's the logic we're thinking about. Here, no. Here, oh yeah, you could actually work some stuff out. You know how that's 100 if we really wanted to. Say we wanted to work this stuff. So these two, can you see here? So I want you to just picture OBD. Can you see we've already found out that's 100? What do you think these two are going to be? They're going to have to be the same. The whole thing's going to have to be 180. It's 40, that's 40. So we know that's 40. And we know that's 40. Now do you notice here they actually tell you this is a, what's it called? They're saying that this bottom bit is also an isosceles. But do you see they gave you it here, but they didn't give you it here? So in the end, we are actually going to be able to work out this whole angle ODC. So if we think of the bottom one, we know that's 130. And we know that we've been told these two are isosceles. So these two have to add up to 50 to make this whole thing 180, and they're going to be the same. So that's 25, that's 25. So you know that bit is 25. So can you see this whole angle here adds up to 65? Quite a hard question though. So that's how you'd work that out. And remember, this is just from us. Did you see how many different circle theorems are used in this question? Quite a lot, right? Here, we've already done this question, haven't we? But yeah, these two will be the same. See that bit of that radius, but we don't care. We've done that question. This is actually probably one of the nicest, but you will forget. Sometimes you just won't spot it. No, nothing here for the rest. Let's go to the next one now. Okay. Boring subject. Okay. What is the next one? Let me just kind of try to remember one. Okay, yeah, reasonably simple one. So imagine there's a tangent. Yeah? All a tangent is something which, it's a straight line which touches the circle at one point. I don't know why I drew that. And imagine now, so there's the tangent, and imagine a radius. So do you see how that's a radius? So wherever a tangent and a radius meet, you get two right angles. So that's what it is. So you might get something like this. it's touching there. And someone might tell you that this is 75. Well, and they might tell you to ask you to find this. Well, we know that's a right angle because that's a tangent and a radius meeting like that. So this, you know, all of this would have to add up to 180. Now, if you just treat that as 90, basically find out pretty quickly that's 15, as long as I haven't messed up my maths there. So yeah, let's try to see wherever a tangent meets with a radius. So there's no tangent here, so it's definitely not here. No tangent there. Is there any tangent here? Yes. Okay. Can you see this C and A? I mean, this line would keep going, so sometimes they won't draw you the whole tangent. But imagine that going on. Now, do you see the radius meets it here? That means that this is a right angle. Similar to here. Do you see this is a tangent? Yeah? Well, that means this is a right angle. See that? Well, and now let's think about this. So remember, this question is asking us to find out this thing. DOA. But we find as many angles as possible. Now, if we be smart about this, can you see that we've got a triangle like that? Well, we know that's 34. We know that's a right angle. So immediately we know this angle as well. So what is that angle? 56. See that? Okay, so that's all we know for now. I'll tell you just a little bit more. Here, doing anything, angle of BOA. What's that? Work out size of angle BOA. So it wants this angle. So it's almost like you've got to draw your own line. That's never going to come. They're never going to give you a question like this. You don't have to ever draw your own lines. But they want you to find this. Well, that actually kind of becomes useful. Because can you see, like, if you drew that, that'll be the right angle. See that? Funny enough, if you drew it to there, that'll also be a right angle. This is a rubbish question, so I don't really care about this. It's rubbish, by the way, because it will never come up. That's why. So, okay, so do we have anything going on here? We actually do, by the way. We do. Yeah, this is actually sort of an interesting one. So, we actually here know that this whole thing, do you see this is a tangent that will keep going like that? We know that this whole thing is 90. Can you see this is a tangent that will keep going as well? So we actually know that this whole thing is a 90, which actually makes it, which actually means we can find this whole thing, because that's 90. So we've got this kind of thing going on. This is a right angle. This is a right angle. This is 86. What does that have to be? 74. It's totally wrong, isn't it? Let's get my calculator out. 94. Obviously, just testing you. Yeah, so that's 94. Which automatically, do you remember from before that these are, by the way, if you see them, just label it like that. This was x because we had these, an isosceles, that's a radius, that's a radius. So x actually we now know. So, because of this, basically. Found out this is 94. Found out this is x, this is x. So we can actually work out x. 180 minus 94, 43. So we found out that's 43 as well. Bloody messy stuff. Okay, so now we've found the angle marked x, just like that. Do you see that? So we knew, by knowing this little trick, found that's 43. Incredibly messy. Hope that's somewhat clear. Now this is actually a pretty good one, this question. And you can actually do this now. Firstly, do you see here's the radius meeting a tangent at the same point. This is a right angle. So explain why OAB is a right angle. Well, AB is a tangent and OA is the radius. Or something like radius and tangent. Basically looking for radius and tangent. The reason I'm not kind of going into huge detail about the explanations and stuff is, I mean, I know for a fact when you guys see like anything which asks you to explain, you're just like, what do I say? How do I say it? However, virtually I've never seen anyone get these questions wrong. As long as you understand why, just write down whatever. You will get it right. So yeah, so let's have a look at this. You've got to work out the length of BC, which is that length. Now, this was a tough question, by the way. I mean, I wonder how many marks that is. Oh, I've cut the bottom bit off, so I don't know. But a good amount of marks. So you need to find just that length. Now, this is the way. I'm going to plug my battery in. Now, here's the logic of this. I want you to first realize that if we could find this, well, firstly, here's the first thing you have to know. Do you notice how that's a radius? Well, this is also a radius. So this bit here is 6 centimeters. See that? Because that's a radius. O to C has to be a radius because O to A is a radius. So if we can find this whole length out, then if we just take away 6, we'll get BC. Now have a look at this thing. This is what we have. And if you spot this, it's easy. It's just that spotting this is sort of tough. So it's actually pretty easy to find this length out because we have a right angle triangle and we know two sides. What do? Dun, 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 dun. Pythagoras. Alright, so this is what the deal is, you know. So we do that. Yeah, this is equal to 100. It's pretty easy. You know, x is going to equal 10 because the square root of 100 is that. So this whole length is 10, which makes this 4. Tough question. So this is 4 centimeters. Here, no tangents, and nothing here. No tangents. Do we have a tangent? Yes, we do. Yes, we do. So, okay, so this is going to help us work stuff out. So we need to find that angle. But look, do you see here and here? This is a right angle. Yeah? Now, do you remember? So now, because of that, we now have a triangle where this is 36, this is a right angle, and we need to find that. Well, that's going to be pretty easy. It's 54. So we now know that this is equal to 54. But do you remember from before? And you might have to recap this video once before, or hopefully you've been kind of printing this out and making notes with it. Or you should actually be trying, I mean, if you watch any of the videos, I should have, you know, you hear me barking about, you should be trying these questions as you go along. And you should be doing that anyway. So anyway, do you remember before we found that this one, this angle here, is double that angle. So that means this is half of that, which makes this 27. I'll work out AOD, which is this one, it's 54. ABC, which is this one, 27. Give reason for the answer, it's half. Don't worry too much about what I write. See, is that, can we see it in action anywhere else? Yeah. Well, we know that these two are now equal. We know that this is 90. So if we find x or y, we automatically know the other because we know they're equal to 90. Does that make sense? Tangent and thing. Do we actually know anything else apart from that? No. Oh wait, there's a little bit of prove that this is, oh, this is a proof question. You need to prove that ROX, wait, ROX. Oh, okay, actually, oh yeah, not yet, we can't work that out yet. So any other question here? I think we've done this question, right? ABD. Oh, actually, yeah, this we can actually now work out now. Do you see here? Tangent meets here. So this is a right angle, and this is a right angle. Remember, we're trying to find out this whole angle. Well, we've done it now. Because we know that this whole bit has to equal 90. We know this bit equals 35. So this bit is just 90 minus 35. Does that make sense? Because this whole thing we know is a right angle now, because tangent, well no, tangent and radius. That bit's 35, so that bit has to be 55. Happy with that? 55 and 35. Here, what are we going to find out? Oh yeah, we are actually going to now be able to find out something. So here's the first thing. Can you see that and that? So we now know this bit here. So this whole bit is 90, by the way. So that bit now is 90 minus 58. So that bit's 32. Yeah? And actually we know that this whole angle is going to be equal to that whole angle as well, because that's an isosceles. Does that make sense? Yeah, but we know that bit there, just that bit, is 32. But we don't know this whole angle is going to be equal to that whole angle. So if we know that, you see, if we know this, if we ever find out that angle, then we'll be able to find these two angles out, because these two will be the same, and this will have to add up to 180. And that means if we know this whole angle, yeah, we could find out this. It wants OTQ. This is the angle it wants, by the way. Let me colour that in red because it's becoming an absolute mess. Hopefully you sort of follow me. Circle theorems are one of the hardest things to explain over a video, but hopefully it's making sense. Yeah, this black and red bit is going to equal, well, it's going to equal something, but yeah, we need to find out basically. Yeah, so I'm just confusing myself as well. Okay, so hopefully that's making sense. Let's go to the next circle theorem. Alright, so here's a pretty interesting one. And now we're going to let's talk a little bit more about tangents. So imagine you have this point in space. So this point is outside, yeah? And we've got a circle, and we've got that's a center. So imagine you've got two tangents coming, yeah, from the same spot. So one of them comes here, and one of them comes here. See that? And imagine you've got this other thing which kind of meets at like radiuses. You know what the craziest thing I find about these circle theorems? Where would this ever come in use in real life? But it doesn't matter. It doesn't matter, because you're going to have to answer it in your maths exam. So okay, so basically you've got one tangent, so one point making two tangents at these 2 points. Yeah, just tapping the circle. And then you've got two radiuses joining those. Well, here's what it says. If you put a line through here, you've got this triangle here and this triangle here. They are exactly the same. They're exactly the same. What do I mean by that? So this first triangle, it actually says two congruent triangles. So it means this angle here, it's almost like this one folds over onto here. So this angle here is going to make this angle here. Well, this is actually a right angle every single time, because can you see that radius is meeting, tangent and radius meeting? But it's also the same there. And then finally, these two, obviously, by the way, because these two are the same. These two are the same. But also, this length, if this is A, this will be A. If this is B, this length will be B. And this one's obviously going to be the same, because that's the same length anyway. So it's basically a point out in space with two tangents, meeting at these 2 points. Then there's a point in the middle, center. They meet. You got two exact same triangles. So basically, look for a point on the outside, look for the circle, look for the center, and a point outside, and this might be in action. So let's have a look at this. So no point outside, no point outside. All right, here. Do you see this here? Look, a point outside making two tangents at A and B, then joined by two radiuses coming from O. Well, guess what? This triangle here is exactly the same as this triangle there. Now, what's the question actually asking here? Find the angle of DOA. So we need to find this angle. Well, look, by doing that, we automatically know that this is 34, because this triangle is the same as that one, which makes this one also 56. Now, the question is asking us to find out this angle. Well, that's okay, because this is a straight line, so all of these add up to 180. Does that make sense? So you've got a straight line. You know, that's 56. You know, that bit's 56, and you're trying to work out this bit. Well, all of those add up to 180, so 180. 68. There you go. So another one done. Or this one, work out angle BOA. BOA Oh, this one actually tells you something. Angle BOC equals 130. So what's BOC? Right, so it's told us that this one is 130. Yeah, this whole thing is 130. Well, now we know. Can you see that this angle, this triangle here and this triangle here are the same? So if this whole thing is 130, then these two have to be the same. So that's 65, that's 65. We need to work out angle BAO, so that one. Well, sort of easy now anyway. So this one's a right angle triangle, this is 65. This is X, pretty easy. 180 minus 90 minus 65. 25. That's another one done. Probably getting through most of them now. I've already answered that one. But if you did want to cut it, there's no point. But if there was a line like that, this triangle would be the same as that one. There isn't, so we don't need to worry about that. There's one tangent being made here, but there's not another, so we don't need to worry about that. No point outside, no point outside. There is a point on the outside, but look, only one tangent, and we've already answered this one anyway. Anything else here? No. No points outside. That's that one. And which finally brings us to our last circle theorem. I mean, I actually quite, you know. 1 second, can't multitask. What was I going to say? Go on, there you go. Who knows, that might have been incredibly insightful, but we'll never know anymore. So okay, so the final one, and this one is this is quite considerably the hardest one to spot. And I'm going to try to break it down as best as I can, but this one used to really annoy me when I used to be doing GCSE myself. It was the one which I'd always miss. But it's reasonably simple. I'll tell you what you need to kind of look out for. You need to look out for a chord. You need to look for a chord and a tangent. So imagine you've got a chord happening from here, yeah? And imagine you have a tangent. So can you see here, you've got a chord and tangent meeting at one spot. You meet at one spot. Now here's what I want you to do. So tangent and chord meet at one spot. Now from this tangent, imagine that there's a triangle being made on the other side. So basically when I say the other side, I mean not here. Yeah, because this is the side of the tangent and angle meeting. Okay, so happy with that there? And here's literally it. It basically says the chord and tangent meet. So imagine this whole angle here is 61. Well, it basically says the angle made here on the other side of the tangent at the other edge is also 61. Bloody annoying to know. So actually, funnily enough, can you see on this side you've actually got this tangent and the this chord and the tangent meeting. So if we knew this one was 85, then can you see on the from this side tangent to the other point here, this would also be 85. So let me give you like a sort of example. So here you go. Tangent. Yeah, now from there's a tangent. Imagine that's the chord. And imagine a thing like this. So someone might give you something like this. 52. Look at this, okay? Here's the chord and the tangent making a thing like that, making an angle like that. That means this angle here has to be 52. By miles the hardest to spot. So let's have a look. You should be looking for a chord and tangent meeting. Do you see a chord and tangent meeting? And if you do, then see if that chord makes a triangle on the edge on the other side. No tangent. No tangent. Well, yeah, you do actually have a. So do you see here? Well, no, you don't have any chord and tangent meeting. You have this tangent, but that doesn't meet with the chord because this one just ends at the center. If it was meeting, if it was something like that, well, then you might be sort of interested. No, nothing here, no chord and tangent meeting. Answer that, answer that. Have we answered this? Yeah, answered this as well. No, not there. Here. Well, this is actually interesting. So you see, you know, in this one, do you see how this chord meets with this tangent? So if I knew that x, if I knew x was 80, say from this chord we made an angle there, well, this would be 80. You see that? But that's actually interesting, because if that's 80, then we know immediately that would have to be double that, so that would be 160. But yeah, but that's not the question here anyway. These are answered. So okay, this is where it gets interesting. Now here's what I want you to spot here. Do you see that this chord meets this tangent? Do you see it in what was it? And that's a 58. Yes, so we know that angle's 58. Now look, from this chord there is a triangle made on the other side. Well, what does that tell you? This one tells you that this angle here, this 58, has to be the same as that 58. Yeah? So this one is 58. Well, now we know these two angles because it's an isosceles. That's what this sign means. So that's 58. We now know these angles. So here's what we do. 180 minus 58, which tells us what these two add up to. And then we divide it by 2 to find out what the angles are. Which is pretty relatively straightforward anyway. So both of these add up to 122, so if we divide by 2, we know that these are 61. Remember, we're just trying to find the red bit. So now listen, we know something about this 61. We've already found out from this mess. So we know all of this whole thing adds up to 61, if I can do a decent line. And do you remember before, this black bit here, which I'm now colouring green, is actually 32. Which makes this one, well, if this whole thing has to add up to 61, 61 minus 32, it's 29. This one is 29. Ugly question. That's the hardest one to spot. Yeah. So, long-winded, boring, headache, sure. Yeah, it's the circle theorems. But yeah, getting a little bit of practice. And here's what even I recommend you do, even if you don't feel fully comfy with them yet. And you know, you can go online and practice more, and then look at the mark scheme and try to figure it out, and you will get good practice from that. But even just reprinting out the sheet again and trying to do it without looking at the answers, but more kind of thinking, well, why am I doing this? Can I spot it? You will get better at this. Right, so I hope that helps, and yeah, I'll catch you on another video.